So we are looking now at the most difficult part of complex number, which is the root of a complex number. Now this here we are talking about the sixth root of a complex number. So let's consider it. If I had, let's say that z6 is equal, I don't know, some form of a number. I'm making that up, so I don't know actually what will be the outcome. So normally in this case, what will we do? It says that z will equal the sixth root of our number. So that's exactly the same principle that we're going to be applying here, meaning that if I am looking for z, that means I am taking the sixth root of minus 64i, and in this form there is nothing we can do about it because the theorem, the one that can help us, work only with powers. So how do I change my root into expression with power? So the formula in our table, let's actually have a look. The formula in our table here is saying, oops, didn't want to do that, is saying that 1 divided by a to the power of p will equal a minus p. Sorry, that's not the formula. This is the formula. It's the red dots that distracted me. Yeah, let's write that. Let's get that here. So this formula basically means that if I want to change the way it is written, that means that becomes a fraction. And that's what I have here. So that means that is z taken on the other side, what I have, it is taken to the power of 1 over 6. Now I can work the numbers here. So how does it work? Well, the first thing, we need polar form of our complex number. So polar form, we need, that's r cos of theta plus I sin theta. So that's the polar form. Therefore, to find the value of r, we take the real parts to the power of 2 plus the imaginary part number without I to the power of 2. That together will give me the value of r. The value of theta will be tan minus 1. First, the b value, so the number that stands beside I over the real value. And as well, we need to always consider where that number is in the context of our question, of our the diagram. Okay, so let's apply numbers. So that value of r, now we don't really have a real number here, isn't it? So if we have nothing maths, that is 0. So 0 to the power of 2 plus number that stands beside I is minus 64 to the power of 2. And we put that in the calculator, press equal, and we get that is 64. That's fine. Now the problem we are having here, if I'm going to replace those values, that means on the top of the fraction I have minus 64, on the bottom of the fraction I have 0. We do not divide by 0, therefore the value of theta is 0. But how come that we are getting 0? Now what we actually have here, that's the reason why we always check where our complex number is in the context of the diagram. So since my real value is 0, okay, so I know that this is my real number, so 0 is here. Now the imaginary is minus 64, so it will be somewhere here. So that's actually where I'm going to have my z. So that means this is the angle I am considering. Therefore, if I want to find out 360 minus 3 times 90, 1 times 90, we are getting 270, isn't it? Because those 90, 90, 90, that's what we are having. So that's our theta. So now we can write our complex number in polar form. So 64 cos of 270 plus I multiplied by sin of 270. And let's not forget that all of that is taken to the power of 1 over 6. So once we've written polar form, the next thing we need to write that in general polar form. What that means, that we basically add to my angle another 360. So that means cos, and now my angle will be 270 plus 360. And the reason why it is n, because I'm saying there can be more than just one turn of a circle. And then I multiply by sin 270 plus 360. And the difficulty or the work with complex number is not that it's that much complicated. It's just you have to be meticulous because there is a lot of writing here. So polar form, general polar form. And now at the next stage, I am applying actually the theorem. So applying means what? We know that this value here is taken to the power, so 1 over 6, and then my angle will be multiplied by 1 over 6. And yes, I can kind of work those numbers to make them smaller if I want to. Or not, I can do that at kind of the next go. So that let me just make sure that we understand that's the angle here. Now, what we were told today, I mean, in this question, we don't need to look for all the answers because there will be actually 7 of them. We are looking only for the 2 values. Why am I saying 7 of them? Because if that is saying 6, I'm starting from n equals 0, and I go therefore all the way to 6. So here we are only looking for the 2, so we can pick the first one, n equals 0, which is fine. What does that mean? I'm replacing that n with 0. So that's my 64 to the power of 1 over 6 cos, let's see, 270 multiply by 1 over 6. That is my first, that is my first value, plus 360 multiply by 0, multiply by 1 over 6 as well. Now we know all of that will be 0. Oh, I'm missing I here. I sin, and again, 1 over 6 by 270 plus 1 over 6 by 360 by 0. A lot of writing. That's all what it is. So then when we put in our calculator, because from polar form, we are going now back to rectangular form. So we take this number, multiply by this cos. And when I know it takes a skill to put that in our calculator, that will give us square root of 2. And again, we take that number and now we multiply by the sin of this angle. So again, that should give us square root of 2. So that is one complex number, the first answer. And then we go again, is basically the same thing. This time we are putting 1 in place of n. So that means cos, and it will be 1/6 multiplied by 270 plus 360 multiplied by 1 multiplied by 1 over 6 plus I multiplied by sin 1 over 6 by 270 plus 1 over 6 by 360. Oh, I'm missing 0 here. Multiplied by 1. And the same thing, we take that and we multiply that by the cos of this angle. And again, we take that and then we multiply by the sin of this angle. So here, what we should be getting from the first calculation, minus square root of 6 plus square root of 2 over 2 plus I. And then the second calculation will give us square root of 6 plus 2 over 2. So like I'm saying, it's not particularly difficult. It's just it takes a lot of steps. So again, let's remember, we change that first to be the power because the theorem deals only with powers. It doesn't deal with sorts. First, polar form, then the general polar form, which is basically adding 360. And then we are applying the theorem, which means the value of r is taken to the power while angle is multiplied by that value. And then in this case, because they are looking only for 2, so first 0 in place of n and then 1 in place of n. And then calculator and back to the rectangular form.